When we're dealing with discrete probability distributions, the first thing that we need to do is determine whether a distribution is valid or not. We have to go through two properties in order to determine that it's valid. The first property is we have to look for each probability for designated x values and make sure that the probabilities fall between 0 and 1. So x takes on a value of -10 with probability 0.1. 0.1 is between 0 and 1. X takes on a value of 0 with probability 0.8. 0.8 is between 0 and 1. X takes on a value 10 with probability 0.1. 0.1 is between 0 and 1. So I can say the first property is satisfied. All probabilities are between 0 and 1. Check. Second property is I need to add together the probabilities and see that they equal exactly 1. So the first probability was 0.1. I'm going to add to that the second probability 0.8. And then I'm going to add to that the last probability of 0.1. When I add those together, 0.1 plus 0.8 gives me 0.9. Plus 0.1 does give me 1. Both of the properties are correct here, which means the overall probability distribution is valid. When I go to do the same steps for question 2, the first step is to check that all the listed probabilities are between 0 and 1. 0.01 is between 0 and 1. 0.02 is between 0 and 1. 0.03 is. 0.04 is. 0.5 is. 0.2 is. And 0.1 is. So since each of them, for all 7 values, 1, 2, 3, 4, 5, 6, 7, the probabilities are all between 0 and 1, I can say that this property is satisfied. All probabilities are between 0 and 1. The next property is I have to add everything together. So for property 2 here, I'm adding together 0.01 plus 0.02 plus 0.03 plus 0.04 plus 0.5 plus 0.2 plus 0.1. When I add these together, 0.01 plus 0.02 gives me 0.03. 0.03 plus 0.03 gives me 0.06. 0.06 plus 0.04 gives me 0.1. 0.1 plus 0.5 gives me 0.6. 0.6 plus 0.2 gives me 0.8. 0.8 plus 0.1 gives me a total of 0.9. 0.9 is not equal to exactly 1. For that reason, this is invalid. Basically, I've proven that this distribution does not fit the second property of a valid discrete probability distribution. Now that I've gone over what valid and invalid are, I can take the valid one and in question 3, find the mean, variance, and standard deviation for this probability distribution. The mean, or in other words, the expected value, E of x equals mu, which is the mean. And that mean just is found by taking each individual x value and multiplying it by its probability, then adding together the results. So the first possible x value of -10 is multiplied by the probability of it occurring, 0.1. Then the next possible x value, 0, is multiplied by the probability of it occurring, 0.8. Then the last possible x value, 10, is multiplied by the probability of it occurring, 0.1. When I do these multiplications, -10 times 0.1 gives me -1. Anything times 0 gives me 0. And 10 times 0.1 gives me +1. When I add these all together, -1 plus 0 plus +1 just gives me 0. Saying my expected value for this probability distribution is 0. So this expected value, or mean, is the correct answer to the first part of this question. I now can use this to find the variance. The variance of a random variable x, or in other words, sigma squared, equals the x value in question, in this case negative 10, minus the mean that we calculated above, 0, quantity squared times its probability, 0.1, plus the next x value, 0, minus the mean, 0, quantity squared times its probability, 0.8, plus the last x value, 10, minus the mean of 0, quantity squared times its probability of 0.1. When I do this out, negative 10 minus 0 is negative 10. When I square negative 10, I get 100. So this becomes 100 times 0.1. Plus 0 minus 0 is 0. Squared is still 0. 0 times 0.8 is 0. Plus 10 minus 0 is 10. Squared is 100. So this becomes also 100 times 0.1. 100 times 0.1 is 10, plus 0, plus 100 times 0.1, which is 10 again. So I get a variance of 20. Now that I have the variance, there's only one more step to find the standard deviation sigma. That equals the root of the variance I found, or the root of 20. When I did that in my calculator, I got a rounded answer of 4.47. So again, the methods that I'm using to calculate the mean formula is you take each individual x value times its probability, add that to the next x value times its probability, add that to the next x value times its probability. It just so happened that this had a mean of 0. That's definitely not common. It's just the way that this distribution was created. That said, whatever the mean that I get, I need to subtract from each x value, square the result in order to do the variance equation. This should kind of take us back to the old variance equation that we had, where we do each data point minus the mean squared, and then we'd add up the total of them and divide by how many numbers there were. We aren't doing that step where we divide by n minus 1 because we're multiplying by the probability as we go along. So these three things aren't equally likely. This middle one happens 8 times as much as either of these outside ones. If we'd added everything together and divided by 3, we wouldn't really be getting a true picture of what's going on in the distribution. This new variance formula, instead of dividing by everything, multiplies by the probability of each thing occurring, which is how we have to treat it when we have things that are not equally likely. We still do the same thing, though, when we get a variance answer to then take it to standard deviation. The same relationship exists where the square root of the variance finds us our standard deviation. Here we're given a situation where we have to make our own discrete probability distribution. So we're told that we get 1 slice 30% of the time, 2 slices 40% of the time, 3 slices 20% of the time, and 4 slices 10% of the time. So I'm going to set up for my probabilities. I'm either going to get 1, 2, 3, or 4 slices. If I want to change these percentages into decimals, I'm just going to divide by 100. So 30 divided by 100 gives me 0.3. 40 divided by 100 gives me 0.4. 20 divided by 100 gives me 0.2. And 10 divided by 100 gives me 0.1. So these are the number of slices I get with these probabilities. When we're then asked, what's the probability that more than 1 slice is purchased? Well, more than 1 doesn't include 1, so I don't count this. But 2 is more than 1, 3 is more than 1, and 4 is more than 1. So what I'm going to do is add the probabilities of each of them occurring. 2 occurs with probability 0.4, 3 occurs with probability 0.2, and 4 occurs with probability 0.1. 0.4 plus 0.2 is 0.6, plus 0.1 is 0.7. So 0.7 or 70% of the time, we're getting more than 1 slice. For at least 3, that does include 3. At least 3 says 3 or more, so it includes 3 or 4. 3 slices occurs 20% of the time, or 0.2, and 4 slices occurs 0.1. When I add them together, 0.2 plus 0.1 gives me 0.3. Finally, we're asked to find the mean and standard deviation for this distribution. So to find the mean of the expectation, E of x, which equals the mean, equals the first x value, 1, times its probability of occurring, 0.3, plus the next x value, 2, times its probability of occurring, 0.4, plus 3 times its probability of occurring, 0.2, plus 4 times its probability of occurring, 0.1. When I do 1 times 0.3, that gives me 0.3. When I do 2 times 0.4, that gives me 0.8. When I do 3 times 0.2, that gives me 0.6. And when I do 4 times 0.1, that gives me 0.4. 0.3 plus 0.8 is 1.1, plus 0.6 is 1.7, plus 0.4 is 2.1. So I wind up with a mean or an expectation of 2.1, saying on average, that's how many slices we get, 2.1 slices. That leads us into our variance calculation, variance of x, or sigma squared. In this case, we start with the first x value, 1, and then we subtract the mean that we found above, 2.1, square the result, and multiply by the probability of getting one slice, 0.3. We add to that the same calculation for 2 slices. So 2 is the x value, minus the mean of 2.1, quantity squared, times its probability of occurring, 0.4. Plus for 3 slices, minus 2.1, quantity squared, times its probability of occurring, 0.2. Plus for 4 slices, minus 2.1, quantity squared, times its probability of occurring, 0.1. So I did this out previously on my key. What I ended up with was this first one was 0.363 plus the second one, which was equal to 0.004, plus the third one, which was equal to 0.125, and finally plus the last one for 4, which I got to be 0.361. That gave me a total of 0.853 as my variance for the number of slices got. Once I have that 0.853, then I can take the square root. So sigma equals the root of sigma squared. In this case, the root of 0.853 gives me 0.924. So basically, the calculation is for mean, x value times its probability, add them all together. For variance, x value minus the mean, quantity squared, times probability, and I add it all up. Let me just double check this one. This should be 3 minus 2.1 is 0.9. 0.9 squared is 0.81. 0.81 times 0.2. Yeah, I'm sorry. This is a little off. Like he has it written 2 different ways. This should really be 0.162. Sorry. 0.162. Let me make sure that this adds up right real quick. When I do 0.363 plus 0.004, it becomes 0.367. Plus 0.361 would give me 0.728. 0.728 plus 0.162 would give me 0.894. Sorry about this. My key has something written and then blacked out, so I believe that if I put this in as 0.894, then I get to the root, which is really 0.944. I really should have a better key for this. Apologies. Double check the math here, put it in yourself and make sure you're getting the thing that lines up. I think that it's still going to be the same thing that you're selecting on the Canvas quiz, but I don't have a calculator here with me. I left them at school, so this looks better to me based on what this one should work out to. I believe this should be 0.894 that then becomes 0.944.